This video shows a demonstration of the Thru-Put APS software application version 7.0, release 158.10. During this Thru-Put application overview demo, we will review the flow of data between ERP and other systems in place and the Thru-Put software application at a high level. We will also review the business functions involved in running the Thru-Put application. Then, during the demonstration itself, we will review how Thru-Put helps the purchasing process, how it allows planning to manage resource capacity and create detailed schedules, and how customer service or sales uses Thru-Put to load the plants. Finally, we will review the key to achieving results, how to manage shop floor execution throughout the whole supply chain. Here's how Thru-Put uses data from the host systems, as well as the information it generates and sends back to them. First, the static data from one or several plants or warehouses is extracted and sent to the Thru-Put database. At pre-planned intervals, Thru-Put runs a complete MRP explosion using the data from the ERP system. It creates a plan or optimized schedule and sends back critical information to the ERP or host system. Namely, a plan or a detailed optimized schedule, a list of planned orders that need to be released to support demand, as well as exception messages. It's important to note that regardless of the number of warehouses in place, Thru-Put creates a plan for the entire supply chain in a single MRP run. This allows the Thru-Put user to get a global view on all supply chain issues. For instance, if a PO in Plant 1 will cause a shipping delay in Plant 3, Thru-Put provides full visibility to the shortage as soon as data is updated. Thru-Put is fully integrated to all of Infor iSeries-based ERP systems. So if a new Thru-Put customer also uses ERP-XA, ERP-LX, or System 21, also called Aurora, there is very little work involved in installing and connecting Thru-Put to the ERP. In general, Thru-Put is connected and can start working within a few hours. Here are the business functions typically involved in running the Thru-Put application. Demand management, production and engineering management, and procurement or purchasing management need to be in sync to achieve high on-time delivery and velocity with the lowest possible inventory and operating expenses. We sometimes refer to this model as the OTD three-legged stool because in manufacturing, all three areas of the business literally support the on-time delivery performance of the company. As an example, if production and engineering produce at the right pace to support lead times, but sales and customer service keep overpromising unrealistic delivery dates, on-time delivery falls. During this demonstration, we will show exactly how each business function uses Thru-Put to achieve the goals highlighted in red at the center of this model. Thru-Put was carefully created to push users to achieve 95+% on-time delivery with minimal operating expenses and supply chain inventory to support demand. For this Thru-Put demonstration, we will use the beginning of the time horizon as July 31st, 2017, and we will be looking at a 30-day planning horizon ending on August 29th, 2017. Using the Thru-Put software application is extremely easy. If the user gets lost or confused about what to do next, the Steps menu always shows the next available step in the process. Thru-Put has its roots in the drum buffer rope or DBR concept, which is in fact the application of theory of constraints to manufacturing. The first three steps of theory of constraints, identify, exploit, and subordinate, are present in the user interface. Let's start with the first step, the identification of material constraints. After considering all demand and supply in place, Thru-Put explodes the bill of materials and calculates the timing of all necessary purchase production supplies. This initial bar chart displays all issues with purchase parts sorted by severity. Let's look at one example. The fifth material in the list, a purchased titanium bracket, has a 5-day raw material quote-unquote lateness. This means that the material is available 5 business days after it is really needed. When looking at the demand supply picture for that part, here the left side of the colored column shows the supply and the right side shows the demand that needs this purchased raw material. We see that it has one past due requirement on July 24th, which we can't expedite since today is July 31st. Thru-Put shows this severe shortage in red. In this case, we can't do much except find out when the demand using that part will be available. So let's accept the push out and find out when we truly can deliver that demand. In this example, going to session results shows us that order 14, initially due on August 4th, will be delivered on August 9th. This is obviously not our preferred choice since, ideally, nothing should be delivered late, but in cases where we scrap, damage, lose parts, or start late due to various reasons, it is better to calculate the impact and communicate, at least internally, the new demand delivery date. So we took care of one issue for this part. However, this same titanium bracket has another red issue. Purchase order number 15, currently scheduled to arrive on August 3rd, is required today, July 31st. Let's say that we called our supplier and they accepted to expedite the quantity required, 148 parts, and deliver them today. The user can go in Thru-Put and change the PO delivery date and resolve this particular issue. When going back to the initial screen, the red issue has disappeared because we accepted a push out in one case and expedited a PO in another for that bracket. The user is now ready to move on to the issue on the next part and decide how to handle it. To support Thru-Put, purchasing or planner buyers peek into the material constraint screen between 2 to 5 times a week to make sure that supplies are perfectly aligned with demand based on the latest data updates. This is always done prior to planners creating the schedule using Thru-Put, and it is one of the keys to minimizing raw material inventory to support the output of the plants. The material planning session ensures that all material issues are reviewed before creating and executing schedules. Keep in mind that this functionality gives us visibility across the entire supply chain. For example, if a purchase order to deliver a part to our Mexican fabrication plant is delayed, the material constraint screen will show us all demand that will be impacted in our U.S. assembly facility, for example, so we can react accordingly. Staying on top of all material issues as they occur on a regular basis is the role of procurement or purchasing with Thru-Put. Let's now move on to the production and engineering capacity management side, starting with rough cut capacity planning. Again, going through the steps menu leads us to the second available option under Identify, which is machine constraints. Thru-Put first shows us a screen called Load to Capacity Chart. A list of horizontal bars displays the process time in green and setup time in yellow for all facilities, let's call them resources, across the entire supply chain. At the top, a percentage scale indicates the ratio of load versus capacity for each resource during the selected planning horizon, so in our case between July 31st and August 29th. To the right, the total process time needed from production and the capacity during the horizon is shown for each resource. Daily capacity for each resource is defined in a simple, easy-to-maintain calendar user interface. Each resource can have its own unique and precise calendar or use a common calendar structure such as day shift, evening shift, or night shift.
Resources come in all forms. They can be machines, work centers, labor pools, individuals, tools, even space. Engineering resources, if they need to be closely managed, can and should also be identified as necessary resources in Thru-Put. In this demo data, for example, most resources are work centers, but we defined assembly work centers, their number starts with ASSY, to model groups of workers that are required for final assembly operations. This load to capacity chart basically tells us that we have 3 resources loaded over 100% during the next month. If we drill down to see more details within the month, we can see that the most loaded work center, the MLG11X resource, a milling work center, has a significant amount of past due orders as displayed in the first quote-unquote bucket on July 31st. You can follow the blue line, which represents capacity, across daily buckets at first, followed by weekly and monthly buckets. Each block on this graph represents a job on this work center. Beige-colored blocks represent released work orders, and green blocks represent planned work orders. At this stage, users can drag and drop work orders to a different location or a different bucket, or let the logic of Thru-Put move them where they should be produced, as we will see a little further. On this graph, cumulative load and cumulative capacity over time are also displayed by a red and yellow line. At this stage, if we want Thru-Put to automatically resolve capacity shortages and create optimal production schedules, we need to identify and tell Thru-Put which resources are constraints. We do this by simply right-clicking on resources we want to pick, and they automatically appear on the list of selected resources. I will go ahead and pick the top 2 resources as constraints right now. There is no limit on the number of resources that can be selected as constraints in Thru-Put, but keep in mind that only a few resources are really dictating the pace of the supply chain, and the highest focus should be put on those. It is not necessary to declare all resources as constraints in Thru-Put. The software will automatically create detailed schedules on all resources, constraints or not. Once resources have been declared as constraints, we are ready to create detailed schedules. Once again, we go to the Steps menu and select Exploit Harmony Next Drum. The term drum is borrowed from the DBR concept. Drums are essentially resources that dictate the beat of the factory. After doing its calculations, Thru-Put shows us a level-loaded schedule on the first constraint we selected. Let me zoom out so we can see a longer time horizon here. We are now seeing a level-loaded schedule in a Gantt chart across all 3 identical work centers available on that resource. Each block represents an operation on this work center that needs to be produced on this resource. When a block is green, it means that all demand consuming this part will be delivered on time. When it's red, it means that at least one demand consuming this part will be late. There are a lot of late jobs in this demo data, and that is on purpose. We simply want to show how Thru-Put deals with a large number of late jobs. When we click on a block, that block turns blue, and all details pertaining to that operation are displayed at the top. On the right side, we see the work order number if it is released. That field is blank when it is not released or if it's planned. And the job exact start and end times. In the middle, higher level information is available, such as part number and description, operation number and description, the necessary tool, the family, etc. On the left, the demand, in other words, customer order, forecast, or safety stock for which this job is produced, is displayed with associated target date. Throughout the entire throughput system, detailed pegging information is available. This tells planners exactly where each job is going and can help them make decisions in the schedule. At this point, planners are required to make decisions to create a feasible schedule. In case you're wondering, this white space early in the schedule was intentionally left blank to illustrate the fact that Thru-Put understands the link between predecessor and successor on the shop floor. For example, this work order here is late, but it can't be done earlier. In fact, dragging and dropping it earlier will have Thru-Put give us a warning saying that this operation can't be moved in. Bringing up the whole chain of linked parts by right-clicking on the block shows that it can't start earlier because the previous production step on resource FRG100, which is a forge, must be done before we can start on this resource. There are a number of Thru-Put tools available to the planner to get more jobs on time on this resource, but they far exceed the scope of this overview. So I'm going to proceed quickly here and use a couple of cool tools. I'm going to first tell Thru-Put to look out 3 days in the future and try to find similar parts to save setups without jeopardizing deliveries. Thru-Put tells us that it was able to group jobs, save over 40 hours of setups on this resource, and make more jobs on time. Second, I will tell Thru-Put to apply automatic overtime per the overtime policy strictly defined in this resource's calendar, and Thru-Put surgically applies overtime. We can look in session results to see how much overtime it allocated and where. And it made a significant number of late jobs on time, as we can clearly see starting around August 17. A lot of jobs that were red, meaning late, are now on time. Since we've tried everything we could, as a last step, I will tell Thru-Put to tell us which jobs will be late and when they will be delivered. Again, this is not the preferred option. It is the last resort. With this demo data, here are the orders that will be delivered late based on this resource's capacity limitations. I will now proceed quickly here and show the exact same process within a few seconds on the second resource selected as a constraint. Again, going back to steps, exploit, next drum, I will go ahead and add overtime, accept the pushouts, and move on. Finally, we ask Thru-Put to create detailed schedules on all resources that were not selected as a constraint. However, the schedule of non-constrained resources will and should be subordinated to the constraint schedule. To do so, we go back to steps, subordinate, and finally write schedule pass. When necessary, Thru-Put can schedule resources that use a very complex shift structure. For example, this Thru-Put Gantt chart shows a schedule in which assembly teams contain more people on the day shift than on the evening or night shift. This chart shows exactly when capacity increases at the beginning of the day shift and when it decreases at the start of the evening or night shift. After planners create a Thru-Put schedule for all resources, a number of simple reports become available in Thru-Put. If the data is transferred to the ERP, reports and graphs are also available to authorized ERP users as well. This is the beginning of the execution phase. For example, this Thru-Put report shows a summary priority list for a resource previously selected as a constraint. It shows the day, part number and description, operation number, and quantity. This report can be used as is and dispatched to the shop floor for execution. Thru-Put allows any authorized user to verify material and capacity availability in the entire supply chain at any time, anywhere in the world. It also allows users to check the detailed status of any demand currently in the system. Here's how it works. Users authorized on the network simply need to open a browser, enter their username and password, and select the plant they want to access. A number of options are available in the main menu. For example, to check the status of an existing order, click on Reports, Waterfall Reports, and enter the order number or simply the part number you are looking for. In this example, I'm going to ask for the status of all orders for part CMPLC10. All orders for that part then appear. I will go ahead and check the status of order 23 for Ford as an example. What appears then is a graph we call the waterfall chart. That chart shows everything that has yet to be done on that order. In this instance, this order currently has work in process at a welding operation. And when that operation is done, it will still need to go through a number of work centers that create subassembly IMPAS2. Then that part becomes an RTA 0C75. And finally, we create our finished product, CMPLC10. Finally, that entire order becomes available on August 16th. If the supply chain planner option of Thru-Put is installed, the product structure for the entire supply chain will show up in a step-by-step waterfall structure. The waterfall will show us exactly each required step within each plant. Let's now exit the waterfall report and see what Thru-Put can do with new orders or new demand. Before we exit though, note that all reports available in Thru-Put, we looked at one earlier, are also available via this web browser. To look at the impact of new orders, we need to access a menu called CSW, which is short for Customer Service Workbench. This is where new demand can be entered and where Thru-Put provides information about delivery dates and cost. Let us select the Add New Order menu, and as an example, I will ask Thru-Put to quote a date to deliver 10 CMPLC10 compressors, the same part we saw in the waterfall before. I will specify that we can start to build the order today on 7/31 and go ahead and hit quote date. After a second or two, Thru-Put comes back and gives us a August 23rd delivery date. We can then click on the successful link to find more details, and here Thru-Put shows us a lot of information. It shows us that for this new order we're going to consume capacity on 2 constraints, or also called drums, that we need to buy a number of raw materials, also consume some POs already on their way, and it also shows us a complete waterfall showing us exactly how this order will be built. Let's have fun and play around with a couple of options here. Let's go back to the initial screen and say that our customer, Ford, is on the line and he's really unhappy about the August 25th delivery date. Let's say that the absolute latest he will accept our order is August 23rd, 2 days earlier. We enter the date in the menu, 8/23/2017. The quantity stays in place, and we hit this time check both to validate that both the quantity and the date we are requesting can be hit. Thru-Put comes back and says no. In normal conditions, without disrupting any other demand in the schedule, you can't get 10 parts on August 23rd. If we click on the unsuccessful button, Thru-Put once again tells us exactly why at the top as well as in the waterfall itself. We simply need more constraint capacity right here at the top. But here's an idea. If we ask this customer to swap other orders for this one, we might be able to satisfy him without disrupting the shop floor. Let's hit the disruptive option here at the top. This table shows us every demand currently consuming capacity on this constrained resource, and this column shows us how many hours each demand is consuming. By scrolling down the list, we see orders for Ford. Some of them don't consume capacity at this time. And if we select order 49, which is consuming 26 hours of capacity on our constraint, when we only need 5.5 for the new order, and hit reschedule down at the bottom, let's see what happens. Scrolling back to the top, it says yes, we can deliver this new order on August 23rd. However, we must ask Ford if they would be okay to postpone order 49 until August 24th from the initial date. This can be done by disrupting orders for other customers as well, but it is easier to ask one client to swap his own orders instead, of course. In addition to swapping capacity or materials between customers or orders, Thru-Put has other tools to allow some expediting, but at a cost. For example, let's cancel this option and come back to our initial demand, which is 10 parts for August 23rd. Okay, here we are. 10 parts for August 23rd is again not feasible. The main CSW screen offers other options, such as adding overtime to deliver orders earlier. Let's try it. Let's check the Allow Overtime button and see what the system says. Let's click on Check Both again, and there you go. With overtime, we can deliver 10 parts on the 23rd, but at what cost? Let's look at the details by clicking on the Unsuccessful button. Thru-Put tells us that we need some overtime at a premium to be able to deliver this new order without any other disruption in the schedule. There are a number of additional features available in CSW that allow users to consider other factors, such as what if we can expedite all materials by selecting Ignore materials? Those are raw materials. Another example is, could we get partial deliveries between now and the 25th? Or what if we expedited the entire order and made it quote-unquote skip over every order on the shop floor by using aggressive time buffers? However, demonstrating all these advanced features is beyond the scope of this overview. The CSW tool, however powerful, needs to be used very carefully. I'm sure you can imagine the chaos that could be created by abusing the functionality you just saw. In general, we allow casual users to browse CSW and train key people, generally in planning or scheduling or customer service, to take more advanced and more disruptive actions in Thru-Put. Handle with care is the advice we give all users here. Keep in mind also that the CSW module allows power users to make decisions that help minimize disruptions in the schedule in place. Keeping schedules as stable as possible is a very important factor in the quest for 95% plus on-time delivery. In conclusion, we must state that the Thru-Put software tool is absolutely necessary, but not sufficient for manufacturers on their quest to 95% on-time delivery. Increasing on-time delivery at a low cost is possible, but each department must trust Thru-Put and the data it contains. They must learn to collaborate and behave in sync with each other. The Thru-Put tool is designed to allow each key department to play their appropriate role in the management of demand, production, engineering, and procurement. Please visit our website to view case study videos in which our customers share their experience and results with the Thru-Put software tool. You can also see our contact information and find additional information on Thru-Put.